Namaste everyone. In this video we are going to solve a problem on kinematics. We have a problem in this case concerned with range. So initially if we have been told that we have a body A which is a hit which is moving with initial velocity of 16 meter per second at an angle of 60 degrees, right? And it's going to reach some target at this point. Let's call it as B. So from A it's reaching a point B. So there are two things we have been asked to find. So first thing is we have to fire another object at an angle 45 degrees so that it has the same range. So we've been told to find this velocity we need to find. So just for convenience I'll just call this state as 1 and this state as 2. So we have been told to find the initial velocity in case 1 and initial velocity in case 2. So we know the formula for the range of the object in this particular case, that's given by u square sine 2 theta by g. So let's first find the range in case of the first object, which is thrown with 16 meter per second. So that's going to be 16 square times sine, the angle is 60 degrees, so 2 times 60 and divided by 9.81. Let's calculate this. When we do the calculation for that, we are getting 22.6, and of course it's in meters. So now for the first object we need to have the same range, so that means R1 is going to be 22.6 and we are supposed to find the velocity u, that is u1. So R1 will be equal to u1 square and sine 2 times theta. So theta has been given as 45 degrees over here, so let us substitute that and divide it by g. So this implies that the range is 22.6, that's equal to u1 square times sine 2 times 45, that is 90 degrees, and this total value is going to become 1 divided by g. So this implies that u1 will be 22.6 into g, that is 9.81 under square root. Let's find that. We're getting it as 14.89 meters per second. So one thing you observe here is when the angle is 45 degrees, we will need much lesser initial velocity to attain the same range. Let's go ahead and see what happens if we want to have the same height. Fine. So whatever height is attained by the first object, we want the same height to be attained by the object, but instead of 60 degrees we are firing at 45 degrees and we are supposed to find the initial velocity. For that we will be using the formula for maximum height, which is u square sine square theta by 2g. So let us first find the height reached by the first object. So for which we'll have to substitute u equals 16 and theta value as 60 degrees. So let's give 60 degrees, and of course we need to make it squared and divided by 2 times 9.81. So let's calculate it. When we do that calculation, we are getting a value 9.79. Now this is the maximum height, so it's going to be in meters. So now our object, which we are firing at 45 degrees, is supposed to have the same height. So the same height edge, this time we need to fire with velocity u2 square, and the angle theta is going to be 45 degrees instead of 60 degrees, so sine 45 degrees, and again we need to square this, and of course we just need to whole divide it by 2.2 into 9.81. So this implies that the height is 9.79. Let's substitute this. So that's equal to u2 square, which is unknown, and into whatever this is, this side whatever it is, we just need to substitute it. Let's go ahead and do that. Okay, so okay, let's move it Actually, instead of calculating it like this, we'll have to make it rounded off. So let's directly go here and find the value of u2. We have to send it up. So 2 into 9.81 will go in numerator into height h, that is 9.79, and the sine square value will go to denominator. So sine square 45 degrees will appear over here. So this, if you calculate, will give us the value of u2. Sorry, this is going to be u square. So we get u square, u2 square is equal to 384.16. And if we take square root, that's when we will get the value of u2. So let's go ahead and take square root of this. Okay. So doing that will give us the value of u as 19.6. Of course, this is in meters per second. So that's it. That's it for this video. We'll take up another problem in the another video. Till then, goodbye.